So he's saying a 0.2 kilogram block is initially at rest on a rough horizontal tabletop. A student then pulls the block across the tabletop with a constant horizontal force of 0.75 newtons. After being pulled a distance of 2 meters, the speed of the block is 3 meters per second. The amount of energy dissipated by friction between the block and the tabletop is most nearly how much? So first of all, what we are searching for the energy dissipated by friction. This one. So energy dissipated by friction is equals to the difference between the work done by the student on the block minus the kinetic energy, the change in the kinetic energy happened to the block. That's it. If we apply this one, we are going to get the right answer. So let's find out each part separately. So first of all, we are going to find the work. Work is equals to force multiplies by distance multiplies by cosine the angle. This is a formula to find the work done. So how much is the force? Let's see. Yeah. A block across the tabletop, the students will then pull the block across the tabletop with a constant horizontal force of 0.75 newtons. So we can say that the force is 0.75 newtons. What is the distance he pulled it? 2 meters. And since he was pulling it horizontally, so the angle will be 0. So cosine 0, it's 1. So we can write it or not, it's up to you. So cosine 0, it's going to be 1 at the end. So let's calculate this. 0.75 multiplies by 2 meters multiplies by cosine 0, we will get 1.5 joules. Work is also, the unit of work is joules. 1.5 joules. So right now we are done with the first part of the equation. Let's find the change in the kinetic energy. So we are going to do kinetic energy final minus kinetic energy initial. So change in kinetic energy is equals to kinetic energy final minus kinetic energy initial. We know the formula of kinetic energy, it's half m v mass multiplies by velocity squared. Of course, this one is mass v final, and minus half m v initial squared. Let's apply the numbers right now. Have the mass is same. How much is it? 0.2 kilograms. So 0.2 kilograms. What is the final velocity? Let's figure it out. After pulling the distance 2 meters, the speed of the block is 3 meters per second. So the final velocity will be 3 meters per second. Okay. Minus have the mass is same, which is, since it's the same block, 0.2 kilogram multiplies by the initial velocity. A block initially at rest, that means that the initial velocity will gonna be equal to 0. So all of this part will gonna be cancelled out. So let's calculate the rest. So right now let's zoom a little bit to the problem. Yeah, it's better. So right now the answer will be half multiplied by 0.2 multiplied by 3 power of 2 will give us 0.9 joules. So it's okay, great. We got work, we got change in the kinetic energy. Let's find out the energy dissipated by friction. So he applied a work, let's write it there. So he applied a work of 1.5, but the kinetic energy that we got after he applied the work is 0.9. So we lost some of the work that we applied regarding of the friction. How much we lose? We lost about 0.6 joules, I think. Yeah, 0.6 joules. So this is the dissipated energy regarding the friction. First one is wrong, second one is wrong. The answer is C, 0.6. That's it.